In this episode, we're going to be checking out HashiCorp's Nomad. Nomad is a pretty cool tool for generic workload orchestration. But what does that actually mean? Well, Nomad is sort of similar to something like Mesos, Docker Swarm, or Kubernetes in that it allows you to do container orchestration. But Nomad is pretty generic in that it allows you to do non-container-based application orchestration too. We'll cover both these use cases via a few demos later in the episode. Since Nomad can do both non-container and container-based orchestration, this makes it pretty unique. Just as a quick recap, let's quickly chat about what orchestration is and why people are using it. Well, say for example that you have a program that runs really well on a single machine, but you need to run that across lots of machines, maybe because you need added compute resources or you're looking for high availability. This is typically what you'd use application orchestration for. It allows you to go from a single machine to running things on multiple machines and offloads a lot of the operational complexity to an orchestration tool like Nomad. But it's not really that simple in practice, since you might need to modify your application to work with the orchestration tool, or maybe change the architecture of your application to support this. But that's the general idea behind orchestration. To me, orchestration really means when you want to make the leap from running things on a single machine to running things on lots of machines, all of a sudden all this operational complexity will appear. Things like, how do I deploy with zero downtime? How do I check if my applications are actually running? If they fail, can I restart them? And are they healthy and all that kind of stuff? So orchestration software like Nomad does all that for you, and it can really lighten the load of your operations team. So let's jump over to the containers in production map for a second. I see Nomad falling into the container orchestration category here, along with tools like Mesos, Kubernetes, Docker Swarm, etc. However, I think of Nomad as a little more generic and less opinionated than some of these other platforms, as it supports multiple methods for task orchestration besides just containers. It's also not tightly coupled to, say, a cloud platform, so you could easily run it on-prem or in a data center that you control. So let's quickly walk through how Nomad works in general. So back in episode 56 on the Kubernetes, the general explanation, I sort of walked through container orchestration at a high level too, by way of a few diagrams. I'm just going to do the same thing here and explain how Nomad works architecturally. Nomad is a client-server workload orchestration system, and you'll typically have between 3 and 5 server nodes that manage the state within the cluster. Then you'll have a bunch of client or worker nodes down here where your tasks are actually running. In Kubernetes, you might translate this to master and worker node terminology. So these server nodes are chatting with each other constantly and syncing cluster state information, things like the server state, client state, and job state. This information gets replicated across these server nodes here, so that if a cluster leader goes down, an alternate can take over. These servers are constantly keeping track of what's happening on the clients too. So architecturally speaking, this looks very similar to how something like Mesos, Swarm, or Kubernetes might be set up. Although the way Nomad implements this is much simpler and straightforward in that there aren't many moving pieces and it's super easy to debug and see what's happening. For example, with something like Kubernetes, there's tons of moving pieces and supporting services, whereas with Nomad, it's just a single binary and a few configuration files. Just like many other orchestration schedulers out there, you can submit jobs into the Nomad cluster by defining your job in a configuration file and then submitting it to the Nomad API. So let's create a job called example, and we want to spin up a Redis container instance using Docker. The Nomad cluster will validate this as a good configuration, check that there's a worker node that can support this type of workload, and then spin up that workload on, say, worker 1 here. Then say down the road you wanted to move into a high availability mode with Redis, so you want 3 instances of it running. You submit another request for this job into the Nomad cluster, and it will plan and schedule these additional container tasks for you on other available nodes in the cluster. Alright, so this is pretty standard stuff so far in terms of container orchestration. But what makes Nomad different? Well, Nomad supports many different job formats via these task drivers. Let's jump over to the docs for a minute. Here's Nomad's task driver page, and it shows you the supported workloads Nomad can schedule into your cluster. So you can see over here, there's support for things like running containers, executables, Java programs, virtual machines, and more. Let's click into the Docker driver and have a look. Down here you can see the task configuration, and it's defining the driver as Docker, along with some configuration about the image we want to run. Then let's check out the exec driver over here. This looks similar in that we're defining that we want to use the exec driver, and then we're jotting down some configuration about the executable that we want to run. What's neat about this is that it's not even in a container. This is like telling Nomad that you want to run a binary on this worker node. So this could be really useful for batch workloads, or say you have a lot of legacy software that's not in containers yet. Let's check out a few more drivers. So here's the Java driver. This example is defining that we want to use the Java driver, and then the config here is defining the jar file that we want to run. You can also get Nomad to orchestrate things like virtual machines too. So here we're defining the VM driver, and we're defining a virtual machine image that should be run. This is pretty cool, right? So this is why I'm saying Nomad is sort of similar to other orchestration platforms, but different, in that it's very much a generic task orchestration tool because you can use it to run containers, binaries, and virtual machines at the same time, all across a bunch of shared worker nodes. So let's jump back to the diagrams for a minute. We have our cluster here, already running our 3 Redis instances. So what happens if we try to schedule a legacy application that's just a simple binary? Well, we define a job using the exec driver and then submit it to the cluster. Nomad will look for a worker node that supports this driver type and schedule the workload there. I'll show you this in the demos in a minute. Nomad worker nodes enable supporting task drivers on these worker nodes by auto-detecting the supporting software. So say for example you have Docker installed on the worker node. Nomad will auto-detect it and allow you to send containers over there. Same goes for Java, virtual machines, etc. Sort of the key here is that Nomad doesn't install the supporting software for you. So you need to install this supporting software yourself via, say, something like configuration management for whatever workloads you plan to run on these worker nodes. All right, so say we wanted to run some batch workloads too. Well, we create another job, define the driver we want to use, in this case exec, and send it over to the Nomad API. Nomad will again look at the supporting worker nodes and send the job over. This is what makes Nomad pretty unique in that you can run lots of job types, and you only need to install the supporting software on these workers. This makes it a pretty flexible system where you can wire up your old legacy applications with a little bit of hacking. But there's also this concept of community driver support, where you could even create your own task drivers for, say, a workload that doesn't exist yet. So over time, you could have lots of different workload types running throughout your cluster. And you can sort of think of these workers as generic compute nodes. Nomad will manage and keep an eye on all the things for you. So that's Nomad and generic workload orchestration in a nutshell. Basically, you can run Docker, single binaries via exec, Java, virtual machines, and pretty much anything else via these custom task drivers. The core idea here is that you can use Nomad to manage lots of mixed workload types in a pretty generic way. The nice thing about this is that you can now define your jobs and pass them over to Nomad, and it will just make sure they're running, restart it if they fail, and it'll just look after all this general operational stuff in a common way across lots of different workload types. All right, so I've probably chatted enough. Let's jump into the demos. So if you check out the Nomad documentation, there's this deployment guide section, and it walks you through setting up your first cluster. You have the server nodes up here that control and keep track of the jobs running in your cluster, and then down here you have your worker nodes or client nodes, and they're actually running the jobs. I'll admit the documents are a little bit inconsistent about referring to worker nodes as agents, clients, or just nodes. So if you want to play around with Nomad, just keep an eye out since this all means the same thing, and they're just referring to these worker nodes here that are actually running the jobs. So I'm going to work through this pretty quickly and we'll configure a fully functional cluster. What is interesting here is that Nomad is just a single binary for both the client and server nodes and requires no external dependencies other than the supporting task driver software on the worker nodes. So to install it on your servers, you just need to download the binary, move it into a path, configure some init scripts, and deploy a few simple configuration files that define Nomad's role. Using the configuration files, you can tell the Nomad binary what type of mode it should be running in, either in the server mode or the client mode. And that's pretty much it. So for the demos today, I thought we'd spin up an example cluster with 3 server nodes and 5 worker nodes and explore what that looks like. All right, so I'm using Google Cloud here, but you could easily do this on AWS, Azure, DigitalOcean, use something like Vagrant, etc. We're not actually using anything fancy here. We're just spinning up some bare bones virtual machines and installing some software on them. There are scripts for deploying Nomad automatically too, but when I'm trying to learn something new, I typically like to install things manually the first few times, just to learn all about all the dependencies and configuration files. This typically helps down the road when something breaks, and you'll hopefully remember that, oh yeah, this thing needs that, and that might help you troubleshoot. But it can take longer to kind of configure initially. I should mention that once I've sort of done this learning phase, I typically will automate things or look for scripts that automatically allow you to configure this type of stuff. So I typically won't roll something manual and then leave it that way. So I've created 8 virtual machines here, 3 as the master nodes, and then 5 as the worker or client nodes. These are totally stock images with nothing installed yet, except the base Debian operating system. What I thought we'd do is sort of go through a speed run of installing Nomad onto all of these machines. I'll speed this up heavily, and you can find the full details in the episode notes below, but the idea here is that you can at least watch me do the 20-second version of installing each node type as I chat over it. So let's start by installing the server node type first by connecting to one of these servers. By the way, this is the architecture that we're shooting for, as you already know because we went over it in the diagrams. We have the 3 server nodes and the 5 worker nodes. Nothing too fancy, but this is pretty similar to what a smaller Nomad install might actually look like. Alright, so we're connected. First I'm going to download, unzip, and copy the Nomad binary into a system directory. Next I'm going to configure the systemd init script so that the operating system knows about Nomad. Next I'm going to create the Nomad etc directory and populate a few configuration files for our server node config. This is pretty simple so far. The only interesting thing in here is that I'm hard coding one of the server node IP addresses in here. This will allow the server nodes to learn about each other and sync up their state as we bootstrap the cluster for the first time. You could use service discovery for this too, by having these nodes auto-register themselves, but I'm just hard coding it for the demo. Then that's it, we just need to start the Nomad service now. Also, through the magic of video editing, I went through the process on the other 2 server nodes too, and they're configured now. So we have a working 3 server node cluster now, without any workers. We should be able to run Nomad server members and get a listing of the 3 server nodes. Great, it worked. Also, if I run netstat-nap and we grep for a list, we should see a listing of ports Nomad is listening on. This is kind of a quick hack I use quite often to find out what ports a certain process is listening on, just by using netstat and then grepping for the process name. So this port here, 4646, is where the HTTP API and web interface are located. So I want to jump back to the Google Cloud Console and add a firewall rule that will allow me to access this port. This step will depend on the platform you're using, but the goal here is that I want to allow network access from my machine into the Nomad cluster on this port 4646. I'm just going to add an ingress rule that allows traffic from my IP into any machine in the network on port 4646. You probably want to lock this down more, but since this is a quick demo, this is more than enough. Alright, so let's connect to one of the Nomad nodes on port 4646 via a browser, and we should get the management UI. So here's the web interface. You can see there's 3 main areas: jobs, clients, and servers. We have not submitted any jobs yet, and there's no client worker nodes either, so we can only explore the server node section for now. You can see our 3 server node cluster right here, and if we click in here, you can see a bunch of the same information that was shown at the command line earlier. Nothing too crazy. So let's jump back to the Cloud Console where we have our virtual machines listed, and do the same speed run of installing the client worker nodes. I'm just going to show you the sped up version of installing one of them, and then we can do the others behind the scenes. The process here looks very similar to installing the server nodes, only that we change a single Nomad config file saying that we want to run this in client mode versus server mode. So we connect, first download, unzip, and copy the Nomad binary into a system directory. Again, I'm just going to configure the systemd init script so that the operating system knows about Nomad. Next, I'm going to configure the Nomad etc directory and populate the configuration files for the client node config. This is almost exactly the same as what we did before. Sort of the only interesting thing in here is that we're defining a client node, and I'm hard coding one of the server node IP addresses here. This is so that the client worker nodes can register and get in touch with the Nomad server nodes. If this were a real production system, you'd typically be using configuration management here to install these nodes, and use some type of service discovery system rather than hard coding. But since this is just a test, it doesn't matter. Alright, we just need to start the client node now. Again, through the magic of video editing, I've installed the other 4 client worker nodes too. So we actually have a real demo cluster that looks like our diagram now. All of our Nomad server nodes are up and running along with our client nodes. Let's jump back to the console on one of our server nodes and verify that it can see the clients now too by running nomad node status. As you can see, we have our 5 client nodes now. Let's jump over to the web interface and see how that looks and what's changed. Great, so before we just had our 3 server nodes, but now we have a client node section too populated with our 5 worker nodes. Let's click into one of these and have a look. So there's some simple details about the clients along with CPU and memory graphs. Some of this will come alive once we deploy actual workloads to these machines. But the thing I wanted to focus on here is this driver status listing here. You can see we only have the exec driver enabled. The reason is that I only installed a vanilla virtual machine, and then we installed Nomad on it. So if you wanted to enable a few of these drivers, you'll have to install the supporting software yourself, and then Nomad will auto-detect it, like installing Docker on the machine, maybe Java, or maybe virtual machine tools. So again, through the magic of video editing, I'm going to install Docker on one of these machines. By the way, I'm using this tutorial here. Also, all the links for all this stuff is in the episode notes below. So I'm just going to add the Docker repo, and then we're installing the Docker Community Edition. So behind the scenes, I've installed Docker on this machine. I've restarted the Nomad client. And so if we refresh this page, we should now see the Docker driver be enabled. Cool, so you can see the Docker driver is enabled now, and you can see some metadata about it. I guess the point I'm trying to make here is that Nomad is pretty generic, and it's not super opinionated about things. So you can configure Docker however you want, say with some specific network settings or storage settings, it doesn't really matter. Nomad will just deploy workloads to it. This is a strength, I think, and sort of makes Nomad unique, in that if you have something super customized, you can likely get it to work with Nomad. But my personal opinion is that there's so much focus on Kubernetes these days, and there's just tons of tutorials. So if you run into a problem, you can likely easily find help. But if you're using Nomad and you're looking for something, it might not be a little bit mainstream. So if you're looking for something a little bit more mainstream and opinionated, and you don't need general task orchestration, you might be better off using a managed container offering via a cloud provider or something like that versus Nomad. But there's lots of pros and cons to everything. All right, so let's go and deploy a workload to the cluster via the console. So I'm connected to one of the server nodes, and I'm going to run nomad job init. This will create a skeleton example nomad job file with a default configuration. Let's quickly have a look through it. So you can see there's a ton of comments in here, which is really nice when you're trying to learn about this job format. Next, you can see our job block here, and we're defining a task that we want to run within this job. We're using the Docker driver here, asking to run a Redis container with this config. Let's quickly browse through the rest of the example file. So you can define resource constraints, say for example that you wanted to limit the amount of CPU or memory a task can consume. Finally, down here you can ask Nomad to register this job with a service discovery system. Say you wanted to route traffic to it, say for a web service or something. But the thing to keep in mind is that you'll need to roll all your own load balancing, as Nomad doesn't support this out of the box. So you might have to use something like HAProxy, pulling a service discovery solution that's automatically getting updated with Nomad configs or something, but that's sort of out of the scope of this. All right, so let's deploy this example Nomad job into the cluster by running nomad job run example Nomad. Cool, looks like it worked. Then let's inspect the running job by running nomad status example. This tells us key information like job health, how many instances there are, and their status. All right, so we're running a single instance right now. Let's modify the example nomad configuration file and change that to 3 instances by changing the count in here, and then let's save the config file. Then back at the command line, you can use something like nomad job plan and then our config file, example nomad, to ask Nomad to read in our updated config file and check and see what changes need to happen. For me, this is a pretty cool feature, and then it's sort of similar to using Terraform in that you can get it to tell you what changes it will actually do. So you can see we're going from 1 instance to 3 instances here. All right, so now let's run it. Let's run nomad job run and then our config file, example.nomad, to deploy this. So we should be running 3 instances now. But Nomad doesn't have any built-in load balancing, as I mentioned before, or anything like that, so you're totally left on your own to figure this out. This isn't necessarily a bad thing, it's just that this is a little bit less opinionated than maybe what you're used to. So this gives you a ton of flexibility over things like Kubernetes, but it also might not be complete enough for some people. Here's a cool page with load balancing using console. A lot of load balancing solutions will be where you populate a console cluster with some Nomad config about where your instances live, and then you can sort of update a load balancing config using that data. If you're interested in this, here's a kind of a cool doc. So even though Nomad doesn't have built-in load balancing functionality, you can still easily get it by using something like this tutorial. Again, the link is in the episode notes below. So we should have our 3 Redis instances running now. Let's jump back to the web interface and have a look. So you can see we have our example job displayed here. You can see all the instance counts and stuff like that. Everything you see here can also be accessed at the command line too. Also, if you check out the client worker nodes, you can see some of them are running our Redis tasks. This might be useful for checking worker node load and things like that. All right, so that's the container use case, but let's jump back to the command line and deploy a simple executable job that's not in a container and deploy that out into our cluster. So I'm just going to paste this simple Nomad config. using the exec driver running the sleep command. We're going to run 5 tasks in this job across our cluster. One major thing to note here is that since this isn't running in a container, you actually need to make sure the executable and the supporting environment exists on these client worker machines. So you could easily get into a situation which containers sort of solve, where you need to install a bunch of supporting dependencies on these worker machines that aren't using containers. But I'm just running the sleep command here, so it should be very common and it should just work. All right, so let's deploy this using nomad job run and then our config file, legacy.nomad. Great, so we should have this deployed now. Let's jump back to the web interface and have a look. Great, so you can see our second job now, legacy, and you can see it's running our instances. Pretty cool, right? All right, so this sort of gets us back to this diagram of the Nomad cluster running mixed workloads. You can have containers, binaries, Java programs, etc., all across a single cluster, and Nomad will look after all the gory details for you. So this is my quick tour of Nomad and some of the cool features that makes it unique, and sort of a more generic workload orchestration tool versus a lot of the ones that focus on containers only. All right, that's it for this episode. Thanks for watching. I'll see you next week. Bye.